All right, let's take a look at where we're going the next few days. We're going to take a second look at over a lot of these ACP type questions. And so this first one says two neighboring cities are growing at the exact same rate. So I think that's key. So growing at the same rate. We've talked about that, the word rate with exponential functions. So I'm going to put that, underline that. The first city, however, has a smaller population than the second city. So that'll also important. The first city is smaller than the second. The graph illustrates the population of the first city going here. So I'm going to think of F as being my first city. So F of X, let me go ahead and graph this, equals 150 times 1.04 to the power of X. Now let's continue on and see what this question says. It says here, if the second city's population was twice as great as the first city's initial population, which graph represents the population growth of the second city? All right, so the second city is twice as great. There it is. The second city is twice as great. And since the first city is called F, I'll call the second city S. So S of X is going to be twice as great. Now, what does that mean? That means the population has twice as many people. Now, one of these is population, one is the growth rate. As it turns out, this is your population right here. This is your population, and this is the growth rate. Growth rate. There we go. And so what happens is the growth rate stays exactly the same, but the population gets doubled, which means you get multiplied by 2. Now you might know that 2 times 150 is 300, but I'm just going to type it in like this to the calculator. Now, right now, I'm not even seeing the same graph, and that's because my axes are different. So what I'm going to do here is I'm going to press this graph settings, the wrench up in the top right of Desmos, and you'll see right on this word x-axis these two numbers. That tells you how far left and right to go on your x-axis. So this goes from 0 to 20. So I'm going to go ahead and just change this to a 0 to 20, get my x-axis aligned. And then over here on the y-axis, it looks like we go from 0, that's 100, 200, 300, 400, 500, and this would be 600. So I'm going to go from 0 to 600. Even though it doesn't say 600, I'm going to do it just because the graph does go up that high, 0 to 600. And if you're wondering what's this label, well, that just tells you that this is the x-axis. So I'll put an X there. Notice that appears. I'll put a Y there so I can see the axis. Okay, whenever I take away the wrench there, you'll see I'm now zoomed out, and this graph perfectly matches because we're aligned. We've aligned our axes. So we're seeing the exact same image. Now, if I graph this, I should get the picture of my solution. So I would just graph this in. And I'm going to turn mine off because I want you to do it. But if you graph that equation there, it should exactly appear as one of these 4 answer choices. And that's how we do a problem of this nature. So a big part of this problem is understanding how to set up our axes so it looks like this graph. Now, if you don't zoom out right, you're likely going to get the answer wrong. If you just say, try to zoom out a little bit like this, if you try to zoom out straight, if I just zoom straight out like this, you'll get a wrong graph because it's not zoomed accordingly. Like this red line is supposed to represent this graph there. So notice you need to get your axes aligned correctly by hitting the wrench, changing this to 0 to 20, and then your y-axis from 0 to 600. And that way you can get the correct picture when you graph this one.